Number 4 reads, John and Tracy look from their 71-meter high rise balcony to a swimming pool below. Yeah, not very realistic to jump 71 meters. But that's okay. Not exactly below, but rather 15 meters out from the bottom of their building. They wonder how fast they would have to jump horizontally to succeed in reaching the pool. What is the answer? So, little Jackie Chan physics for you, little stunt physics. So, the first step is, let's make a little sketch. Okay? So here we are standing at the top of a high-rise condo building. John Tracy here. And they're wondering how fast they need to jump off this building to land into a swimming pool 71 meters below. Crazy, right? And not miss and not die. Splash. Okay? And the question is, well, how fast do you actually have to run and jump off sideways? So again, the key thing is to realize this is velocity in the horizontal direction. Okay? Let's go ahead and look at the numbers carefully to put that on our diagram. So what do we know? We know that John and Tracy are 71 meters high and the pool is 15 meters out. What's 71 meters high? That's really your delta what? Your delta y, and 15 meters out is your delta what? X, okay? So you see how visualizing the problem helps you figure out what the numbers really mean, and that's kind of the whole point, okay? The math actually isn't hard once you break it all down. So delta y is 71 meters high, and technically is that positive or negative? It's going to be what? Negative in terms of how far they fall. If it's positive 71 meters tall, that means they fall negative 71 meters, okay? And the delta x was, what, 15 meters, right? And that's how far sideways out the pool is. 15 meters. Good. Now we're ready for step 2. We're going to break down all of our knowns and unknowns, okay? And the whole point of this problem is we want to find, well, what is this velocity x jumping off so that you don't die, okay? And we'll do this in meters per second. Delta x is 15 meters. We don't know time in seconds. Those are our 3 variables in the horizontal direction. Vertically, as always, we have our 5 variables for the nifty equations, right? We got VI, we got VF, we got A, we got delta y, we got time. We don't know time, but we do know delta y is what? Negative 71 meters. We know A is negative 9.8 meters per second squared, right? Do we know the final speed at which you hit the water? We don't, and we're not really solving for it, okay? And that's actually useful to know. It's useful to know we don't know VF and that we don't need to solve for it, okay? And now, you got to read into it, what's the VI? What's the initial vertical velocity? Are we jumping up or down? Are we just jumping straight sideways? Just straight sideways, so we can call VI 0, okay? So it's not to say that we're not moving initially, we're just not moving in the Y direction, okay? Your book calls this VYI, but I'm just dropping out the Y, okay? So now, as before, we can plug and chug. We can't solve in the X direction, but in the Y direction, which equation will work very well to find time if I don't know VF? You see how we're getting good at this? Okay? Which one works great? Which one's perfect? We can use equation number 3. It's the only one that doesn't have VF, okay? Delta y is VIT plus 1/2 AT squared. So now when we plug and chug, and we put in our numbers here in step 4, it's easy to know which number goes where, right? For delta y, we put in negative 71. Initial velocity is 0, plus 1/2 acceleration, negative 9.8. Solve for time squared. Half of 9.8 is 4.9. Divide both sides by 4.9. The 2 negatives become positive because we got to take the square root. So time is simply the square root of 71 over 4.9. Okay, doing a little speed algebra on you guys there. If that's too fast for you, just write it out step by step, okay? I'm just trying to save you guys a little bit of time and also save a little screen space on my virtual notebook here. So it's about 3.807. I'm going to keep a couple decimal places till the end. 3.807 seconds. Let me make sure I got that right. 3.807. Yep. Seconds is the time in the air. So I'm about 4 seconds in the air. There we go. 3.807 seconds. And now we can finish this problem by going in the x direction. In the x direction, velocity x is just my change in x over time. Speed is distance over time. Distance is 15 meters. Time is 3.807 seconds. So I'm able to finish this problem by taking 15 and dividing it by my previous answer of 3.806 whatever seconds, I'm getting about 3.94 meters per second. So in other words, if you were to pull off this stunt, if you jump too slow, you'll miss the pool and die because you won't go far enough. If you jump too fast, you'll also miss the pool and die, right? So anytime a stunt double does something crazy in a Hollywood movie, somebody sits down with a pencil and calculator and they run the numbers to make sure that you don't kill anybody. Okay? So in a nutshell, that's number 4.